Welcome to LabMinutes.com. In this video, we will look at how to configure EZVPN with Dynamic Virtual Tunnel Interface, or DVTI. The first question you might ask is, why would I use DVTI over the conventional dynamic crypto map? And there are several reasons to that. First, DVTI allows you to pass both unicast and multicast traffic. So if you have a requirement to pass multicast traffic, the DVTI will support that. Second, the way DVTI works is for every connection that comes into the head-end, there is a dynamically created interface for each connection. So if you need to implement a features or any features that ties to the individual interface, for example, QoS, some firewall feature set, or even network address translation, you'll be able to implement those features on the virtual template. Also, DVTI allows you to implement many functionalities that's very similar to what you can do with the GRE tunnel, but of course without the actual GRE header in the packet, so less overhead for the traffic. And also, with the conventional dynamic crypto map, you match the interesting traffic using access lists, so you have to define both source and destination IPs, but with DVTI, everything becomes a routing function. So the way to force the traffic into the tunnel, it's basically defining a routing that will point to the destination subnet into the tunnel interface. So anything that you want to be passed through the tunnel, you would just need to come up with the correct routing configuration. But with EZVPN, those will be installed dynamically for you when the connection is made by the means of reverse route injection. And because this becomes a routing function, you only have to deal with a single security association, as opposed to if you have to define like multiple subnet with the conventional dynamic crypto map, you might ended up having multiple security association per your VPN connection. Okay, so in this lab, we're gonna be configuring EZVPN using DVTI. We have a router R1 acting as a head-end and R2 acting as a client, and we're going to try to provide connectivity between the two VLAN, VLAN 32 on the left and VLAN 128 on the right. And we're going to look at a different functionality that we can try on now that we have a dynamic interface created. One would be a QoS, so we're trying to implement a QoS policing on the particular connection, as well as we're going to also try out multicast traffic. Okay, so start off with our configuration on R1. If you're familiar with the conventional dynamic crypto map on the EZVPN, the majority of the configuration will be very similar with minor changes, which we will look at in a sec. So first off, we're going to do AAA new model. So we're going to do a simple pre-shared key authentication with XAuth. So AAA authentication, login, call authn local, and then you have authorization, network, call author local. Now we give it a username, site, and password Cisco. Now create an access list for the split tunnel. EZVPN split tunnel ACL with the permit IP of 172.16.32.0, which is our VLAN 32 on the right. Any. Next we go into the phase 1 crypto map policy with encryption AES256, authentication pre-shared key, group 2, hash SHA, and let's just leave a default lifetime 86400. Let's go crypto ISACAMP keep alive interval 10 seconds with 3 retries. We have a crypto ISACAMP XAuth timeout. It's going to do 5 seconds. Okay, next we're going to create the group. So everything so far is the same as the conventional EZVPN with the client configuration group, EZVPN group, with the key Cisco DNS 172.1632.40. That's the DNS server IPs. Let's see what else. Then we have domain name, LabMinutes.com. Okay, then we're going to allow the save password. We're not going to do pool because we're going to use the network extension mode. So save password. And then, oh, don't forget our split tunnel ACL. Turn on PFS as well. Okay. Next, we're going to go into the crypto ICAM profile. Call EZVPN ICAM profile. Okay, going from top to bottom here. I'm going to go with client authentication list, and it points to the AAA authentication config called authn. We're also going to have client authorization. Oh, actually, client configuration. Address. Going to do response. Since the head ends, it's going to be responding to the connection initiated from the client. Then we have ICAM authorization list author. Point back to the AAA authorization command. Next we do keep alive 10 retry 3. Self identity, use the self address or IP address, and match identity. We're going to identify the group. I'll tie it to the EZVPN group name, EZVPN group. And here is the first difference in the configuration. We're going to associate the ICAM profile to a virtual template. So for every connection that comes into the head end will dynamically create an interface, and it will pull a config or build a config of the interface based from this virtual template that you define. So here we're going to call it virtual template number 10. So later on we have to define a virtual template. Next we're going to do crypto IPsec transform set. Again, this is pretty much standard config for IPsec tunnel with the encryption AES-256 with the ESP SHA HMAC. Okay. We're gonna make sure we clear the, hang on, let's see, crypto IPsec TF bit clear. Okay, now instead of creating a bunch of the dynamic crypto map, instead we're going to create an IPsec profile called EZVPN IPsec profile. And the configuration of the IPsec profile is very similar to the dynamic crypto map or the crypto map itself. Here we'll go ahead and set, since this is still a dynamic type of tunnel, we would not match anything. You can see there's just set. There's no match. So everything is set. First, we're going to set security association with the lifetime. And again, you have the two options of kilobytes. So do 1 gigabit, or gigabyte rather. And you got seconds. Just the absolute lifetime, and we'll do 8 hours. Next, we're going to set transform set, and we're going to point that back to the one that we created, which is AES256 SHA. Now we're going to set PFS group 2. Okay, very similar to what we used to have, and then we're going to associate the IPsec profile to the ISACAMP profile. And again, let me make sure I got this right with the ISACAMP profile here. Okay, so that's all you need for the IPsec profile. Next, we're gonna define our virtual template. And we made it number 10 of the question mark. You know, to specify the type and tell it this is going to be type tunnel. Okay, this is very important, because if you leave that out, this will not work. Okay, so usually with the GRE, you will have an IP address on the tunnel interface. Same goes here, but it doesn't really have to be a dedicated IP address. You can just do an IP on number. And here we have a loopback 0, so we're just going to tie to loopback 0. Again, since the tunnel is going to be point-to-point, the actual IP itself is not really important, as long as, because the packet will come in on one side, and since it's a point-to-point, the only way to exit is on the other side. So the IP of the tunnel is really not critical. And to save the IP space, then we can just do a number to the loopback. Next, we have to make sure we specify a tunnel mode, because without that, by default, it's going to be a GRE. So we need to tell it's going to be just a raw IPsec, IPv4. And then to finish things off, we're going to do tunnel protection and tie that to the IPsec profile that we created. There you go. So you can see there's absolutely no configuration on the crypto map, whether it's just the regular crypto map or dynamic map. Everything is defined under IPsec profile. And you don't even have to enable crypto map on the interface neither. So that's would be the differences in the configuration. Next, we're gonna jump to the client side. Again, the majority of the configuration will be very similar without the DVTI. But first, we need to define also a virtual template, since the dynamically created interface also is going to happen on the client side as well. Okay, virtual template temp type tunnel. And on R2, we also have a loopback address. So again, it's going to be IP on number, loopback 0, and then don't forget to set the tunnel mode to raw IPsec. Okay, next going to be crypto ISACAMP policy 10 with encryption of AES256. Authentication pre-share key, group 2 hash default lifetime, crypto ISACAMP keep alive 10.3, crypto ISACAMP XAuth timeout 5 seconds, just to keep consistent configuration on both sides. Now we're going to define crypto IPsec client, EZVPN, ECVPN. Okay, we're going to go ahead and connect auto. Okay, I'm just going to go ahead and assume that you guys have some familiarity with the configuration on the client side. So here we're going to do connect autos automatically connects, so the connection always stays up. We define the group, EZVPN group, key Cisco. Here we're going to do mode, network extension. So no IP will be dynamically allocated from the head end. It's going to be bidirectional access with network extension. Peer, going to point to 11110, which is our IP on R1 public interface, with idle time of 1 hour, so 3600 seconds. We're going to store username, site, and password Cisco locally. And with XAuth, user ID mode, we're going to tell it to use local. And lastly, we're going to tie the virtual tunnel interface so the router knows what interface or where interface template or which one we're going to use. So virtual interface 10, which is the one that we defined earlier. Okay, so you can look at virtual template 10. And then we still need to define the outside-inside interface of EZVPN. Okay, EZVPN outside, and then 0 will be inside. Okay, so here you see there's this interface virtual access one that was just created and now it's up right here. So that particular interface was not there before, we only had a virtual template. Let's see if we can actually look under the virtual interface one at all. Okay, so you could, and you can see, and then let's compare that to the template. Right, so the tunnel source interface is FAST01, so it picked the EZVPN outside interface as the source interface. And it knows that destination came from the group configuration that we did, and the tunnel mode was inherited from the template. Okay, the same thing goes or happens on R1 with the virtual access 1 interface dynamically created. So you do show run interface. With the tunnel source on the outside interface, the mode again inherited from the template. Destination that was dynamically discovered when the connection came in. IPsec profile came from the virtual template. And if you look, the interface IP, since we use IP unnumber, has the loopback IP. Okay, now let's do some test ping. So go ahead and ping. Let's make sure the switch one knows how to get back to that. So if you do debug IP ICMP, let's check our crypto IPsec SA. We do show IP route static. So here you see that R2 has installed a static route pointing to the VLAN 32 out of or into virtual access interface. Okay, on the R1 side, the same thing happened with the static route being installed and also pointing to the dynamically created interface. Okay, and all we have is just one security association between the two peer. Okay, so we have our ping going, and here, although it hits the switch 1, let's see if switch 1 knows how to get back. Looks like it currently has no routes, so you can either redistribute the route, the static route, from R1 into EZVPN and form EZVPN between R1 and switch 1, but here we're just going to install the static route on switch 1 just to keep things quick and simple. So 128.0.255.255.255.0 to 192.16.2.2. Okay, and as soon as you do that, it completes the routing, and we start getting a ping reply. Okay, let me disable the ICMP debug. Okay. Right now that we have the tunnel interface dynamically created, we're going to try to play around with some of the features on the interface. So next we're going to do a QoS. So we're going to see if we can define a QoS policies on the virtual template and see that take effects. So in R2 we define a class map called ICMP, and we get a match protocol ICMP. Okay, let me kill that ping in the background. We're going to do match protocol ICMP. Let's wait for it to bring up that. There you go. So next we're going to do policies map. Let's call it to EZVPN, and we're going to match class ICMP, and we're just going to simply police that ping traffic. Okay. Next we get under the virtual template 10, and we just go ahead and do service policy out to EZVPN. Okay, just to show you, you can also do IP inspect, for example, or CBAC, or you can do IP NAT outside or inside if you want to perform network address translation on that particular connection. Here we have QoS attached to the interface, tunnel interface. So crypto map interface. Okay, next we're gonna go ahead and do a ping from the switch 1. So switch 1 verb site on the right hand side here. Ping 32.1. Let's do repeat 100 and packet size 500 maybe. Okay. So you can see you get irregular drops, which most of the time indicative of some sort of QoS and rate limiting, which we do have. So we go back to R2 and do show policy map interface. You can see we start getting hits on our class map, and we got some conform packet as well as the packet that was dropped due to the policing action. So you can see you can apply a per tunnel type of features with the DVTI. Okay. So next we're gonna show you how the multicast, or see if the multicast traffic actually works. With R1 we're gonna go ahead and enable IP multicast routing. Okay, and again on the virtual template 10, we're going to enable PIM sparse dense. And we also going to join the loopback as for our testing purposes. IGMP join to a group number 239001. Okay, being a receiver of the multicast group. On the R2 side, we're also going to enable multicast routing. And on the virtual template 10, we're going to enable PIM sparse dense. Okay, and immediately you get a PIM neighborship comes up. So if you do show IP PIM neighbor, the interface is the virtual access one that was created when the tunnel came up. Okay, and to prove that the multicast traffic actually works, we're going to ping the group that was joined by the R1 router loopback, sourcing from the inside interface. And here we have received a reply from the R1 loopback address, which is 172.16.0.4, and here is 172.16.0.4. Okay, so you can see that with the virtual tunnel interface, you can encrypt more than just unicast traffic. In fact, in our static VTI video for the Ipsec LAN to LAN, we will actually gonna enable EIGRP, so you can run dynamic routing protocol across raw Ipsec tunnel without GRE. So that saves you the GRE header, was to give you the benefit of being able to running a dynamic routing protocol across the raw Ipsec channel. Okay, so that wraps up our video on the EZVPN with dynamic virtual tunnel interface. Thank you for watching LabMinutes.com. I'll see you guys in the next video.